Hello class. Today we're going to start our lectures on research methods and personality. I know that when I typically talk about things like research methods and statistics, students don't find that the most entertaining of subjects. They would much rather have study something that's more content-based. But the way that I look at this is it's kind of like when your parents told you to eat your vegetables before you could have your dessert. Before you can get to the fun stuff, you have to get to the vegetables, the things that are healthy for you. And before you can understand anything else in the rest of this class, you need to know, how do we evaluate what makes a good personality test? How do we conduct any kind of research on individual differences in human beings? You need to know something about the different kinds of data that we collect in the field of personality. What are the pros and the cons of each of these data types? Because if we don't know this, well, then we're unable to evaluate whether or not what we're going to be discussing in the future is good science or not. What's the flaws of some of the theories that we're going to talk about later on? What are the good things about some of the theories and the tests that we talk about later on? So before we can do all that, we've got to talk about research methods. So we're going to do two things in this module. First, we're going to take a step back and look at two of the major branches of psychology. We can look at all psychology and put it into two different camps: experimental psychology and differential psychology. And these two different psychologists, these two different branches of psychology, study very different aspects of psychology. The way that they conduct their research is very different from one another. And unfortunately, the two disciplines are very fractionated. A bunch of differential psychologists only talk with one another. They write research studies that are only seen by one another. Experimentalists only talk with one another. They're only conducting research studies with one another. And there's not much conversation between the two of them. And they would benefit from communication with one another. And so we're going to talk a little bit about differential psychology and experimental psychology, why they are fractionated, what are the differences between the two different disciplines, and why does that matter when we're studying something like individual differences. And then we're going to go over into some of the different ways that we collect data in the field of personality. Some different data types. What are the pros? What are the cons of each of these data types? So first of all, let's talk about and define and enumerate the differences between experimental and differential psychology. So first, I ask you to read a famous, influential presidential address of the APA by Lee Cronbach. And Lee Cronbach is a very important differential psychologist. He's a very important name in the history of psychology. And in fact, we're going to encounter him and his work a few times across the next couple of modules. So he's somebody that we're going to try to pay attention to. The name Cronbach, you will find, comes up quite frequently in psychology, especially when we're trying to design an appropriate personality test. So in 1957, Lee Cronbach was elected as the president of the APA, which is the American Psychological Association. And as the president of the APA, one of your responsibilities is that at the huge convention, annual convention every year, you give a presidential address to try to, talk about where psychology is headed. And Lee Cronbach delivers this address about these two different streams of psychology: experimental and what he calls correlational, but I'm going to call it differential because I think that differential is a better term for it, and how these two different disciplines, psychologists are trained in either one or the other. They only look at research studies in one discipline or the other discipline. And he was finding that in the early days of psychology, those two were combined. Everybody learned the same kinds of methodology. Everyone communicated with one another. But as psychology was growing, the two different disciplines became more fractionated. And he wanted to elaborate that this is a problem, and that to be well-versed in psychology, you have to know both about experimental methodologies, experimental results, and differential results and methodologies. I hate to say it, but these two disciplines have become even more fractionated. Okay, even today, you are trained in one specific form of psychology, and many times you do not know much about any of the rest of psychology. And this has become more and more prominent over the past years. In graduate school, I talked with someone that was a PhD student at Berkeley. Berkeley, a very good school. She was in the cognitive neuroscience program. And I asked, okay, well, what classes are you taking? Like, what classes do you have to have for your PhD program? And she said 3. Only 3 classes in her entire PhD. And they were systems neuroscience, computational neuroscience, and cognitive neuroscience. Only one of those was a psychology-esque class. This is problematic if you want to be a PhD, if you want to teach. You should be well versed in the discipline. And look, there were no research methods classes that she had. There were no statistics classes that she had. And this is becoming more and more common, where there are fewer and fewer classes that graduate students take. And the classes that you do take are specifically within your own narrow discipline. So psychology has become very, very fractionated, especially with the teaching of psychology, which is why we try to do a good job at the undergraduate level to give you a wide base of knowledge in the field of psychology. So first of all, what are experimental psychology, and what are experimental psychology? What is experimental psychology, and what is differential psychology? What are the goals of these two subsets of psychology? Okay, well, in experimental psychology, we don't really care about individual differences. We don't care about why people are different from one another. We're interested in an experimental manipulation. We change the environment somehow. We give you more time to study or less time to study. We give you this drug or this placebo, and we see how that changes a dependent variable. So we're not interested in looking at variability within human beings. We're looking at variability across groups. So one thing that experimentalists are very, very concerned about is removing all potential confounding variables. Experimentalists are very, very worried about a potential confounding variable impacting the results of their study. So they go out of their way to try to control all of these confounding variables. Here's some examples. In graduate school, if we were doing a measure of attention, or if we were trying to study attention in some way, one thing that we did is we had subjects put their head into a chin rest type thing. What this was designed to do is, well, if you're doing a task on the computer, sometimes you might be way out here. Some people might be like way super close, and that might impact your reaction time to something that appears on the screen. And we don't want that variability. Okay, that variability might lead us to a wrong conclusion. We want to control that confound. So what do? We make you put your head in this chin strap. Okay? And this is something that we always do in experimental psychology. Any potential confounding variable, we try to control for it, we try to account for it, we try to eliminate it. It's very important for an experimental psychologist. So if we're trying to study something like memory, one thing that we might do is have a test that is very dissimilar to what you might have to do in real life. So here is a paired associates test. What we might do is we might pair the word value with Randall, and then later on in the experiment, you might see the word value and you have to respond Randall. I might pair the word tree with lamppost or something like that. And when you see tree, you have to say lamppost. We're using associations that you typically do not make in your everyday life, because if you already have certain associations, that might impact the data, that might impact your results. So if we were to say something like dog, cat, well, you already have an association with dog, cat, and it might be stronger for some people than it is for other people. So it might impact the results of your study. So the point is, experimental psychologists are very, very diligent in trying to remove all of these confounding variables so that they do not impact the scores of the dependent variable. Another aspect of experimental psychologists, they are concerned with between groups variance. They are concerned about the differences between their experimental condition and their control condition. They don't care about the variability within these groups. Okay, they care about the differences between the experimental group and the control group. And if there is a great amount of differences, then they say that that is a statistically significant difference, and our treatment, our independent variable, caused some change in the dependent variable. This should sound very familiar. The majority of times when we teach undergraduate students in psychology, we look at things through the eyes of experimental psychology. For the most part, there's some exceptions. So we're trying to measure between groups variance in experimental psychology. What we try to do within groups variance is eliminate it. Any individual differences among the subjects in our experimental condition, we try to eliminate. We are not interested in that, because if there's a lot of variability in both of our groups, then we're unable to see if there is truly a difference between our experimental group and our control group. So we want to make sure that subjects within each group are almost identical to more easily tell that our independent variable caused a change in our dependent variable. So some examples of this: if you are doing research with rats or mice, a lot of times what you might use litter mates. So you put a certain rat or mouse in the experimental condition, and then you put a certain rat or mouse that was born at the same time with the same father rat, with the same mother rat, into the control condition. So why do you do this if you are a neuroscience researcher or you're studying learning or something like that? Well, the reason that you do this is there's no differences. There's not a ton of differences genetically between these two. They have the same mother rat, they have the same father rat. So their genetics are very similar to one another. Any differences in how those rats perform from one another has to be attributed to our experimental manipulation. Aging is exactly the same. The rats are exactly the same amount of, are equally as old. There we go. That's what I was trying to say. They were born at the exact same time. There's no differences in maturation. One group of rats is older than the other group of rats because they're litter mates with one another. If the mother had some traumatic injury during pregnancy, or she had some really good food while she was pregnant, well, then that's going to be spread across all of her children. So we use litter mates in studies of neuroscience to minimize these within group differences, to minimize these within subject differences. We might try to do this with studies with human subjects as well. If you're an experimental psychologist and you are studying, let's just say, students at UNG. Now, students at UNG are not representative of all human beings, but if we look at on the whole, across all human beings in existence, you guys are fairly homogeneous. You are of similar ages, okay? You're of similar backgrounds. You're raised in a similar place, so you're more homogeneous. And that means there's going to be less variability within our groups. And so it's going to be easier for us to tell differences between our experimental and our control conditions for our experiments. So in that way, just using college students is a good idea if you want to see if your experimental manipulation works or it changes some aspect of the dependent variable. If we were to add, for instance, let's say that we add many older adults to our study. Well, it was the case before. Let's say that we were looking at scores of vision, for instance. Well, vision might vary a little bit if we just look at college students, but if we add older adults, it's going to vary much more. And if there's more variance in our conditions, within our conditions, then it's going to be more difficult for us to see a statistically significant difference between our two groups. So as an experimentalist, sometimes we try to eliminate this with these within group differences or minimize them as much as possible because we are more likely to find a statistically significant effect. For experimental research, for experimental psychologists, they use random assignment to assign subjects to an experimental condition and a control condition. So this subject shows it to our study, and we flip a coin, and if it's heads, they're in the experimental condition. If it's tails, they're in the control condition. And because we do this, we are comfortable in saying that if there's a difference between our two groups, since we used random assignment, then it is truly the case that the independent variable causes a difference in the dependent variable. This is important. Experiments are the only way that we can prove causality, that a change in the independent variable truly causes a difference in the dependent variable. Experimental psychology is the only way to prove causality. Okay. This is something that I'm going to get into the nitty-gritty, but I don't want you to necessarily know the nitty-gritty, just know that there's a difference. Experimentalists have their own specific statistics that they use. Experimentalists use statistics like the t-test, analysis of variance, analysis of covariance. Sometimes they might use chi-squared, but what I want you to take from here is not necessarily what statistical tests those are, although you might have had quantitative methods and some of these might be familiar to you, but they have their own statistics that they use that are going to be different than those of the differential psychologist. In the undergraduate major for psychology, the majority of classes that we require you guys to take are from the experimental perspective. So if we have classes on cognitive psychology, learning, biopsychology, social psychology, sensation and perception, all of these, for the most part, take the view of an experimentalist. In fact, when we teach you guys research methods and when we teach you statistics, the majority of the time we are teaching you from the perspective of an experimental psychologist. Differential psychology is often neglected within the undergraduate study of psychology. Disciplines like developmental psychology and abnormal psychology, they are differential in nature. So human beings might differ on things like anxiety, they might differ on things like depression. Developmental psychology, obviously as people age, that is an individual difference. But many times these problems within developmental psychology and abnormal psychology are viewed as kind of a quasi-experiment. Okay, we have one group of 3-year-olds, have another group of 4-year-olds, and we try to see if there's a difference in some way. That's more of an experimental approach. It's not a true experiment because we're not using random assignment. You can't randomly assign a kid and say, okay, today you're going to be 4 years old, and tomorrow you're going to be 3 years old. That doesn't work. You can't use random assignment. But we look at things oftentimes in developmental psychology from an experimental perspective. In abnormal psychology, we do the same thing. This person has an anxiety disorder. This person does not have an anxiety disorder. And we might look at differences between those two. Okay, so that's experimental psychology. And that's the approach that experimental psychologists take. Now let's look at things through the eyes of a differential psychologist. So differential psychologists are less concerned about controlling for all potential confounding variables. They are more concerned for the fact that their tests and their measures mimic what is found in the real world. They care about they don't want these stale tasks that might seem very dissimilar to what human beings actually do. Remember when the chin strap, it's very, very restrictive. Remember the paired associate test where we're associating words that are never going to be associated like how they are in the real world. Also think about research like that of Hermann Ebbinghaus, who, because he was worried about the potential confound of knowing what some words mean and what some words don't mean, he used nonsense syllables as his to-be-remembered stimuli when he was studying memory. Okay, that's a very experimental approach. Differential psychologists, on the other hand, are concerned with ecological validity. Ecological validity is the extent to which our tests mimic that of the real world, what human beings actually encounter about their daily lives. A good example of this, in graduate school, we were interested in examining multitasking ability, and one multitasking task that was very important for us was that of an air traffic controller. Now, an air traffic controller sits in a tower during their job, and it's their job as planes are coming in to certain runways, as they're taking off, that no one crashes into one another. It's a very, very difficult task, and there's a lot of multitasking involved because you need to know, okay, well, is this runway going to be clear to land? This one plane is coming in this other direction. So it's quite stressful and requires you to kind of have your mind at many different places at once. So to measure multitasking, we decided to create a test that was very similar, or at least somewhat similar, to that of which an air traffic controller would experience in their day-to-day job. Now, we're not trying to control for all potential confounding variables here, like we would in an artificial experiment, but we're trying to get it to mimic what human beings do in the real world. Another good example here of multitasking ability, we have this test that's called cooking breakfast here. Now, cooking breakfast, what you do, it's supposed to mimic if you were to cook breakfast in the morning for a group of people. You have to put the toast in the toaster, you have to start frying up the bacon, but while you're doing that, you have to set the table. And you need to make sure that you're checking the eggs, the bacon, the toast every so often to make sure that they don't burn. So in this test, you start cooking these items, and then you start to set the table, and every so often you need to check and stop cooking these things when they are done so that they're not burnt. A lot of things are happening in this test, but we're trying to mimic it so that it's similar to what human beings might have to do in the real world. Okay, what are differential psychologists interested in? Differential psychologists are not interested in between groups variance. Okay, in many situations, there are no between groups manipulations in a differential psychology study. Instead, we're interested in within subject variance, differences among human beings. This is what we're studying. Now, notice here that for experimental psychologists, they're interested in between groups variance, and they're trying to minimize within groups variance. For differential psychologists, they don't care about between groups variance, and they're trying to maximize within groups variance. So the thing that one discipline is trying to minimize, the other discipline is trying to maximize. What one discipline is trying to study, the other discipline doesn't care about or is trying to eliminate. So we're interested in within subjects variance for differential psychology. So let's say that we are doing a differential psychology study just at UNG. Now, many times we might not find a correlation between something like, let's say, personality and job performance, because everybody is relatively homogeneous. Everybody has relatively the same personality. Well, that's not necessarily true at UNG, but let me give you another example. When I was at Georgia Tech, we were interested in differences in memory and differences in math ability and how math ability might be correlated to something like memory. Now, this is Georgia Tech. Everybody is really, really good at math at Georgia Tech. So if we were to look at a correlation between math ability and memory, even though in the true population, all human beings, there is a relationship between math ability and memory, we are unable to find that at Georgia Tech. And the reason is because the range, the amount of variability in math ability at Georgia Tech has been restricted so much. Now, let me kind of show this to you graphically. Okay, this is called the problem of restriction of range. So if the sample that we decide to study has had its range of scores restricted in some way, we are unable to find a correlation. So we could talk about Georgia Tech and the relationship between math ability and memory. But let's, for this example, talk about, let me give me 1 second here to pull out my little computer marker. Okay, so let's do the example of, is height correlated with basketball ability for those in the NBA? So the taller you are, does that mean that you're going to perform better in the NBA? So we have this graph down here, and this is a scatter plot. So each one of these dots represents a single human being. So on the x-axis here, let's just say that we have basketball ability. Okay, so on the x-axis, we have basketball ability. So I'm going to draw a lovely basketball right here to represent that. Look at how wonderful that thing is. I am an artist. Okay, so we have basketball ability. The further along this axis, the better people are at basketball. Okay, now let's look at the y-axis. On the y-axis here, we have height. The advantages of Zoom class. There are a lot of advantages to Zoom as opposed to Microsoft Teams. Okay, so we've got height and we've got basketball ability here. And if we look at everybody, we can find a line of best fit here that's positive. Okay, the slope of that line, if we're looking at a line of best fit, is positive. We would find a positive correlation between basketball ability and height. But that wasn't my question. My question was, what happens if we look at just the NBA? Is height correlated with basketball ability in the NBA? All right. So again, we have basketball ability on the x-axis. We have height on the y-axis. But instead, this time, we are only selecting those individuals that do the best at basketball. Okay, just the upper 5%, or I don't know what it is for the NBA, probably the upper 0.1% of all people that play basketball. If we look at just these human beings, and if we were to draw a line of best fit here, the line of best fit would be flat. There would be no relationship between height and basketball skill within the NBA. And that's actually what we find. We can do another example of this that you might be familiar with. How about SAT performance? Again, can you tell that art was my least favorite subject in grade school? I bet you could. So we have SAT here on the x-axis. The further we go on, the better you do on the SAT. And we have college grades here on the y-axis. Lovely. Okay, so if we look, a lot of people complain that the SAT is not a good predictor of college grades. And they look at, you know, we go to some college, we look at the correlation between SAT and grades the first year, and it's a very small correlation, and they go, ha, see, we need to get rid of the SAT. It's an awful test. And as it turns out, that it's a bit of a wrong conclusion to make. Because what the colleges do is they might accept a certain amount of people that have a higher SAT score. So here, let's say that I'm going to draw a line, and we're only accepting individuals to the right of this line for college. Now, overall, if we were to draw a line of best fit, we see a strong relationship between college grades and SAT. But if we look at subjects just to the right of this graph, we see that that line of best fit is flatter. Okay, there's no evidence of a relationship there. Okay, so restriction of range is a problem. We need to make sure that we have a wide variety of subjects of different abilities in to find relationships between different variables when we're doing differential psychology studies. So going back to Georgia Tech, so what did we have to do? Okay, what did we have to do if we're trying to find a relationship between math ability and memory ability? So because Georgia Tech students are so high in memory ability, so we need to get other kinds of subjects. So what we did is we collaborated with somebody at UGA because all the people at UGA are bad at math. Boom, slam for UGA. That's not exactly true. Students at UGA are very good at math, but I like to make fun of them, so we're going to do that. We actually took community subjects, so people that just would volunteer in the community that were typically not as good at math as Georgia Tech students. Okay, but had to get the slam for UGA somewhere in there. Okay, where were we? Okay, differential psychologists don't really care about between groups effects or between groups variance. Okay, they don't have an experimental group or a control group, and in fact, many times they don't have a experimental group and a control group. They completely do away with the experimental manipulation. So differential psychologists do not manipulate an independent variable. So I cannot manipulate math ability and see if it has an effect on memory, or manipulate memory and see if it has an effect on math ability. If we're looking at something like how old you are, does it lead to, the older you get, does your intelligence increase? I can't manipulate your age. I mean, we can wait for you to age, but we can't manipulate it. So with a lot of these differential psychology studies, we are not manipulating anything. And because we can't manipulate individuals and put them into the experimental condition and the control condition, we can't prove causality. We can't prove causation. We can't say that this change in this, studying for 30 minutes compared to studying to 1 hour, changes how well you do on the test. We can't say that with differential psychology. With correlational studies, they do not prove causation, as you have heard plenty of times before. So we always have to guess at where causation is. This doesn't mean that differential psychology studies are useless. Many times we study things in differential psychology that we could not do experimentally. So what is the effects of early childhood trauma on mental health? That's a very important question. It's something that we need to study, and yet we cannot manipulate early childhood trauma. We can't say, okay, you 5 children, guess what? You're going to experience trauma today, and you 5 children, you're not going to experience trauma. That would be very unethical. Okay, we can't do that. We have to rely on children that self-report trauma after the fact, which so we're unable to prove causation. There might be some other reasons why there's this relationship between childhood trauma and mental health later on in life, but we can't experimentally manipulate that for ethical reasons. So there's plenty of reason to do differential psychology studies. The kind of statistics that differential psychologists used are those of correlations, regression, some things that you might not have heard of before, but you will hear about in this class: factor analysis, instructional equation modeling. Again, I don't want you to know these specific statistics, except for correlation. We're going to go over a lot about correlation here in the next module. But notice that the statistics are different. And if the statistics are different, that means that everybody in differential psychology can read other differential psychology papers and might not understand the research that experimentalists are doing. An experimentalist can read their own papers, but they will not understand those of the differential psychologist. This is hugely problematic. Okay, where do you, as an undergraduate in psychology, hear about differential psychology? Okay, what kind of classes do you take that you would learn about differential psychology? Well, one is personality. So, ta-da, this class we're going to be talking about differential psychology because we're interested in individual differences in human beings. If there were a class here on human abilities, so things like intelligence, things like attentional abilities, memory abilities, math ability, that would be a course that's on differential psychology. We would take a differential psychology perspective here. but we don't have that class. Cross-cultural psychology, we care a lot about individual differences. And developmental and abnormal psychology, they can be taught in a differential way, and you do get some differential psychology from those disciplines. But in this class, we're going to focus a lot on how to do differential psychology. Also, test and measurements. That class Dr. Halliburton is going to be teaching, or Dr. Halliburton has taught, and it's a good class on individual differences in differential psychology. But again, the majority of time in undergrad, you are taught from an experimental methodology. And that's because of a number of reasons. Experiments are easier to understand many times than differential psychology studies. And experimentalists are more likely to go into academia, more likely to become professors. And so they're typically professors are going to teach the kind of research studies that they have done before, that they are well versed in. Whereas differential psychologists sometimes go into industry. So sometimes we'll work for a company for job selection or something along those lines, or a testing company or something like that. Okay, let's do some caveats about the differences between experimental and differential psychology, some things that are important to note. First of all, differential psychology has gone by a number of different names. I prefer the term differential, and that's what I call it. But as we mentioned before, Cronbach, in the paper that you're going to read or have read, he calls it correlational psychology, and that's fine too. Early in the history of psychology, this was called ethnic psychology. Wundt, for instance, would call this discipline ethnic psychology. G. Stanley Hall would call this genetic psychology, which has nothing to do with genetics, but has to do with individual differences, particularly as people age. Sometimes people use the term comparative psychology to refer to differential psychology. It just depends on the age and the text that we're reading, if it's from the 1930s, if it's from the 1950s, and so forth. But many of these terms mean differential psychology. That's the point that I'm trying to make. This is a point I made earlier, but I think it bears repeating. Both disciplines, experimental and differential, are interested in a type of variance that the other discipline tries to minimize or doesn't care about or tries to eliminate. Experimental psychologists are interested in differences between the experimental condition and the control condition. Differential psychologists are interested in the individual variation within people. Experimental psychologists try to eliminate the variance within people. Okay, that's a nuisance variable for experimental psychologists. For differential psychologists, they don't really care about differences between an experimental group and a control group. The statistics of the two disciplines I mentioned are different, and they are different, but they're based off of the same mathematical model, which is known as the general linear model. So the statistics really aren't that different. They're just different ways of expressing the same mathematical model, and yet experimentalists cannot really read or understand many times when we're reporting differential statistics, and many times differential psychologists are unable to interpret or understand the statistics of an experimental psychologist. It's wild, I know. Just a little bit about the differences in conducting these studies. Experimental psychology is more difficult to plan. You need to think about all of the control all of the variables you want to control, and what your experimental manipulation is going to be. So planning an experiment is very hard. Carrying out the experiment is not hard. Doing the statistics is not hard. There is one difference that you care about between the group A, group B, and the dependent variable, and you see if there's a difference. The statistics are fairly simple and straightforward. Differential psychology, on the other hand, sometimes you might not do nearly as much planning because you don't care about those confounding variables. And the hard part comes in making sense of the data. You've got all of these different relationships. How do you test for them? What statistics do you do? For differential psychology studies, the real big difficulty is on the data analysis. The statistics is much more of the hurdle than the planning the study or getting the study together. So, which one of these disciplines of psychology is better? Which one of these is more rigorous? Which one of these disciplines is more quantitatively savvy? And which discipline is the correct way to conduct psychology? Now, if you've been paying attention, you know the answer already. Remember, I've said that most of the time in psychology, the answer is it depends, or both. And that's the answer here. Obviously it is. And even though that's obvious to you, it's not obvious always to psychologists. There are plenty so let me give you a story. My advisor at Georgia Tech, Randy Engel, started off his career as an experimental psychologist, a very rigorous experimental psychologist, and he moved on and was one of the first cognitive psychologists to really embrace differential psychology. And he tells a story about how some of his colleagues would come to him and say, well, this isn't really rigorous science. This is just kind of some BS. Like, why are you studying correlations? This is not really good science. You need to go back to doing experiments. Now, he shut those people up by showing that his research was very, very important, but there's still those people out there that thinks, well, experiments are the only way to prove causation. Correlations are more wishy-washy, so let's not concern ourselves with differential psychology. And I've seen people on the opposite end. I've seen some people that argue, well, differential psychology is more statistically savvy. These individuals know mathematics better, and so they are better at doing psychology than the dumb experimentalist. And this isn't necessarily true either. What discipline works is depends on the kind of research study that we want to conduct. Are we interested in individual differences in human beings? Are we interested in changing a certain research program to see if there's an effect of something? Like maybe we can change a drug to see if that improves behavior. Maybe we can change how we teach somebody something, and we see if that leads to a difference in behavior. So it really depends on what we're trying to study. So as you've probably predicted, these questions are not very useful. And in fact, many times experimentalists would benefit in what they're studying if they learned how to do differential psychology. Differential psychologists would benefit if they learned experimental methodology. And this is the point that I want to make to you today. So even if you're not going to be interested in differential psychology, it's still important to learn the research methods and techniques within the field of differential psychology. Same thing as if you're a differential psychologist, if you're interested in this kind of stuff, you still want to learn and understand experimental methodologies because it's really going to benefit you and make you a better psychologist, make you a better scientist. And this is a point that Lee Cronbach makes in that presidential address that you guys have read or are reading or will read. So make sure that you do that. And he also gives some examples of some of the benefits that both of these different disciplines would gain if they were to listen to people on the other side. So was it the case that Lee Cronbach fixed the divide and now people are both experimental and differential psychologists? No, the field is more fractionated than ever, even within subdisciplines of psychology sometimes. Things are very fractionated and you don't really talk with your peers that much. Even within the specialized conference that I go to, Psychonomics, it's the Psychonomic Society conference. And everything that has to do with cognitive psychology, so perception, thinking, decision-making, memory, attention, it's all there. And sometimes I'll go up to a poster of an individual studying language, and it's almost like they are speaking another language to me because the way that I do research is very different from the way that they do research. And that's not a good thing. We need to be able to communicate one another. We need to know each other's methodologies because we could greatly benefit from seeing how other disciplines solve their problems. Okay, I believe that's enough of a rant. So psychologists could greatly benefit from a combination of both experimental and differential approaches when conducting research. The majority of time in this class, we're going to look at things through the eyes of a differential psychologist. So we're going to talk about their methodologies, we're going to talk about their statistics, and how to create a good test. All right, there are three major types of individual differences. The first type is a cognitive individual difference. And a cognitive individual difference, these are things that we're typically going to call abilities. So we can think of things like intelligence, memory, attention. how well you are at navigating a maze, or how good is your sense of directions. All of these things we would call an ability, and all of these things are cognitive individual differences. So my sense of direction is awful, so that would be very low for me. But these are, again, things that we call cognitive individual differences. In this class, we're really not going to talk that much about cognitive individual differences, but this is a major type of individual difference. Another type of individual difference is affective. Affective individual differences are things that we might call personality traits. So maybe we can call, some examples of this are extroversion, maybe how emotionally reactive a person is, how happy they are when they meet new people, how often do they like to try new foods. All of these are affective individual differences. The majority of this class, this is where we're going to be. We're going to be studying affective individual differences. The last thing that is often neglected within psychology, but it's still very interesting, are conative individual differences. And if I were a betting man, this is the one that you're most likely to forget about or not remember the definition. So these are things that classify as preferences or desires or wants. So do you prefer to work in a structured environment or an unstructured environment? So do you prefer to work from 9 to 5 every single day and you're told exactly what to do, or do you prefer to be your own boss? This is a preference. So this is a preference. These are things that we're going to call conative individual differences. Do you prefer the mountains or the beach for your vacation? I guess right now, your summer might not have had that much of a vacation, but what kind of vacation do you prefer? Again, this is a conative individual difference. Another example of this, maybe you have differences in your preference for pets. So my wife loves border collies. Okay, so my wife loves border collies. That's her favorite kind of dog. Dr. Harrison, on the other way, well, we're both Dr. Harrison, but this one, me, Tyler, he prefers small white fluffy dogs. I had a small white fluffy dog growing up. I think they're cute. It's the kind of dog that I want. So this is another example of a conative individual difference. So my wife might prefer border collies. Tyler might prefer small white fluffy dogs. This is an individual difference that has to do with preferences or wants. It's a conative individual difference. All right. This is our dog Tara, by the way. She is a cutie. So my wife and I are thinking about maybe getting a second dog. Okay, we've got one border collie. So guess what kind of dog we're going to get second? If you guessed another border collie, you are correct, and you have identified how marriages work. So yeah, so we might eventually get another border collie. I do love border collies too. Okay, there's the different types of individual differences, just to give you a lay of the land. We are going to talk a little bit about conative individual differences when we get to talk about jobs and personality in the workplace. Okay, let's end there for right now, and we'll tackle research methods and personality a little bit later on. Well, I hope you guys are doing well, having a good summer, and have a great day. I will talk at you later. Bye-bye.